All right. So let's look at another problem. Another type of thing we're going to be dealing with here. We might have a problem with something like this. Let's do that. That way. All right. Algebra students.
Is that equals -1 now?
Yes.
Yes, I'm making sure.
So what do we want to do first? We need to apply, oh yeah, by the way, I want x to be an element of the interval from 0 to 2 pi. Alright, that's where x's are. Oh, by the way, what am I working on right now?
Math.
Okay, I'm working on math. But what value am I working on here?
Oh.
Sorry, I need to ask a better question. I'm working on 3x, right? This one talks about x. So, just out of curiosity, 3x would be an element of what?
0 to 6 pi.
Very nice. So what does that imply to me as I'm trying to find answers?
Lots.
Well, lots of numbers, that's true, but also I think it implies that I have to move around the unit circle 3 times.
Oh.
And I'll be getting answers that are 3 times around the circle instead of just once. Okay. We were told, maybe, that we want to apply the inverse cosine of this -1/8. Lowercase cosine, by the way. So my question to you is, what angle or angles directly on the unit circle have a cosine value of -1/2?
2 pi over 3.
Those are the two that I heard?
Yeah. 4 pi.
How many say, yes, I agree with those off the unit circle? Okay, a couple of you. Several of you to the right, looks like. Okay, there's more hands. Everybody understand how I get those two angles?
Yeah, I'm on.
Okay. Now we can test the phone. So, there's my circle.
6 pi over 3.
And we know that 2 pi over 3 is right here, and that 4 pi over 3 is about here, correct? Alright. So on one time around the circle, I'm here. But now if I start going around the circle a second time, and I get to here,
8 pi over 3. 8.
how did you get that?
Because you get. Yes, me. You get. So 2 pi would be 6 pi over 3.
Okay. So you know right here,
Yeah.
and you know that that is
6 pi over 3, and then you add 2, which would be to the numerator, which would be 8.
do we understand that? I got some heads going. No. Okay. Let's try it this way.
And then 10 pi over 3.
What do you want to use for your symbol? Smiley face, star, flower. What do you want to use?
Flower.
Crayon.
Okay. Here's flower first. There it is. So there's your flower.
Why the flower?
I mean what?
Flower.
Make it a little bigger. Now you can see it. Okay? Now, for our first trip around the circle, you can agree that we're going around the circle and we're going to stop right here at 2 pi over 3. And you're going to stop right here at 4 pi over 3. But we're going to keep going around the circle. In our second trip around the circle, we have to stop at this same location. But if you think about going all the way around the circle once and then coming back and stopping right here, how many radians is that?
8 pi over 3.
Well, it's the 2 pi over 3 plus a whole loop around the circle, which is plus 2 pi more. But to add like denominators, you got to have 6 pi plus 2 pi. So we're going to have then 8 pi over 3 as one stop.
10 pi over 3.
And then I keep going down here, and so because 6 pi over 3 plus 4 pi over 3 is 10 pi over 3.
Yeah.
Okay? Is that it?
No.
How many times do I go around the circle?
3.
How do you know that?
Because it says 3.
Well, partly it says 3 right here, but more importantly, it says 6 pi up here. So we keep going around the circle. Where am I going to stop? Right there, right? So if I'm going to go around that third time, I'm going to take this 8 pi over 3 and I'm going to add what to it? So that gives me
25.
and then yes, I come around here and we add another 6 pi over 3 to this one. Let's try adding correctly back there. Okay. So now, if I keep going, I have to stop right here now because this is the end of my third trip. Is that right? So I'm not going to put any other angle values up there. Would you agree with that? Before I move on to do the next thing, do you have any questions for me about how we got there? I do not expect you to have to draw a circle every time on your paper or something like this. Yes, ma'am?
Why do we, in the very beginning, why do we switch to the inverse of the cosine?
Because when I'm right here, I'm saying the cosine of something is equal to a negative half. My question is, how do I find the something? How do I find the angle? Well, what I know from last chapter is the inverse always gives me an answer that's an angle. So I apply the inverse cosine, and that gives me an answer that's in angles. Okay? Other questions? Okay, now, as interesting as that list is, we have to do something with it. No, we're not done yet. Because I want answers that are X answers. I don't want answers that are 3X answers.
Wait.
Okay, oh wait, what?
If you, well, if you divide by 3, I thought you could just get rid of all 3 times.
So I'm going to actually multiply by 1/3. Isn't that the same as dividing by 3?
Yeah.
So X is equal to 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. Are all of those answers within one trip around the unit circle? How many think yes?
Yes.
Hands up. How many think no? How many aren't sure how we tell? We need to know how we tell. If 9 becomes my denominator, remember 2 pi is one trip. So that is equal to how many pi over 9? 18. So I have to be less than 18 pi over 9. Am I less than 18 pi over 9? So that means it should work just fine. We've got 6 answers to this problem. What?
They all have this many answers.
No.
The most of them.